Good evening, everybody. In the last class, we had discussed in the last section of my lecture about the term and the coefficient. Now, today we are going to start from that point. Look at the board. In connection with that article, just we are going to study today the continued product. The continued product. In this article, we are going to discuss how one can multiply given 2 factors, 3 factors, 4 factors, and so on so forth n factors very quickly. Let us see. X plus a1, x plus a2, x plus a3 to x plus an. Say it is p of x. Now we want to multiply this one. Before multiplying this one, just we are going to take a simple example. Look at here. X plus a1, x plus a2. So just we want to multiply it. So we have a general rule. First we multiply this first term with these 2, first and second. So what we are going to get? X square plus x into a2, and then we have to multiply the second term with the first and second term of the second factor. So what we will get? a1x plus a1a2. So in this way we will get the multiplication of these 2 factors. But today I am going to give you a trick by which even you are not able to multiply these 2 factors quite easily, but in fact maybe more than 2 factors, 3 factors, 4 factors, 5 factors, and so on so forth n factors quite easily. Let us see how. But one restriction of this multiplication, what we are going to learn today, is the coefficient of x in each factor must be unity, that is 1. Now you may ask to me, if the coefficient of x in each factor is not equal to 1, then what we have to do? So I do say you have to take common firstly and then use the trick what I am going to give you today. So trick is that firstly take x from each factor. and then multiply and write. So x from this factor comes out to be x square. Now x from this factor and number from that factor. So x into a2. Now x from that factor and number from this factor. Then x a1. So obviously x is the common in both the multiplication. So take x common and then write here a1 plus a2 into x. Now lastly, take numbers from both the factors. So a1 and a2 from that factor, multiply together. So we will get a1, a2. Now this completes the multiplication of these two factors. Now apply the same trick in the three factors. Look at here. X plus a1, x plus a2, x plus a3. So now take x from each factor and multiply it. So it becomes here x cubed. Now x from n minus 1 factor and the number from the remaining one. So here total is 3 factors. So n minus 1, that is 3 minus 1, that is the 2 factors. They take x from 2 factors and number from remaining one. Here altogether is 3. So remaining one is third. So xx a3, xx a2, xx a1. So definitely x square is common in all the three multiplication. So it becomes here a1 plus a2 plus a3 into x square. Now gradually decrease. Take x from one factor and numbers from remaining two. So x from here, x a2 a3 multiply together. X a1 a3 multiply together. X a1 a2 multiply together. So what? We are going to get x is common. So here a1 a2, a1 a3, a2 a3 and then x. Now finally numbers from all three factors. So a1 a2 a3 multiply together. So it becomes here a1 a2 a3. Now just we succeed to multiply these three factors. But mind you, in each of the factor, coefficient of x must be unity. If not so, then we have to make it first and then apply this trick. So genuine question is that, sir, if here is the minus and here is the plus and everywhere minus, then it is applicable. Okay, applicable, no doubt in it. But only criteria is that coefficient of x in every one of the factor must be unity. Now we have to extend this idea there. So what we are going to get from here? Take x from each factor. So x from here, x dot 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 x. If we multiply x n times, then from class 6 we may get x to the power of n. So here the first term comes out to be x to the power of n. Now x from n minus 1 factors and the number from the remaining last. Take into account. So here x up to say here x plus a n minus 1. So x and the number from here n. In that manner we have to make too many possibility to look on and then multiply x n minus 1 times and then one of the number from a1, comma, a2, comma, a3, dot dot dot, comma, an. Then x to the power of n minus 1 comes out to be common. And the remaining, just I'm going to write here, look at. So here it comes out to be sigma a1 x to the power of n minus 1. Here sigma is the notation. This is the sigma is the capital sigma of the Greek alphabet. However, you also know a small sigma here, generally used in surface charge density, surface mass density, etc. So right now, this is the capital sigma, generally used in summation sign. Summation of like term, not unlike term, summation of like term. So here what does it mean? Sigma a1, it means that a1 plus a2 plus a3 plus dot 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 plus an. Okay, so here like that. Now x from n minus 2 factors and numbers from remaining 2. Now it comes out to be very interesting. So what we are going to get this time? X to the power of n minus 2 as a common. And then what I am going to write, really it is very interesting. So here sigma a1, a2, x to the power of n minus 2 and so on and so forth. Just we are going to take the minor as I have used in first 3 term. Finally, so we have to take numbers from every one of the factor. Then what we will get? So here we will get a1, a2, a3 dot 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 an. Now question is, what is a1, a2? That's very much interesting. So just I am going to write for interest what is sigma a1, a2. Look at here, sigma a1, a2. This is equal to a1, a2 plus a1, a3 plus a1, a4 plus dot 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 plus a1, plus a2, a3 plus a2, a4 plus a2, a5 plus dot 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 plus a2, an plus a3, a4 plus a3, a5 plus a3, a6 plus dot 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 plus dot 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 plus a3, an. Now plus dot 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 plus lastly an minus 1 an. This is sigma a1, a2. So look at the way I am writing here. You have to learn. Now just we are going to generalize it after writing 3 terms. Look at here, plus dot 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 plus. Now here again 3 terms, plus dot 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 plus and then last term, plus 3 term and then last one, and finally dot dot dot. So in a minor, here we have to write the first 3 terms for each, and now for a whole we have to write taken as the one, this one taken as the number 2 term, and this is taken as number 3 term up to here, and then dot 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 and then last term. If just after writing two term and just we are going to generalize it and then write last term. No way. It is not permissible in mathematics and hence in physics. If we have the sequence like n term, n plus 1 term, n plus 2 terms, etc. So at least we have to show 3 terms. Sometimes maybe more than 3. In case of arithmetico-arithmetic, so we have to write 5 terms. In case of arithmetico-arithmetic, we have to write 4 terms, like that of geometric, and so on, so forth. So this is the way mathematically, if one can write 1 term and then generalize, that it is their matter. But actually what mathematics says, just I have shown on the whiteboard. Look at. So this is known as the continued product. We are going to use this result to carry out the calculation in quick time. That is why. Now another advantage of this continued product is that we may prove binomial theorem for positive integral index quite easily. Rather, we have a straightforward proof too by using the identity NCR plus NCR minus 1 is equal to N plus 1 CR. However, before using this result, we have to use the principle of mathematical induction. So take it as a PM, we have to prove P1 and we let PM is true. And then we have to prove PM plus 1 might be any variable x and whatever the variable you may choose. By using the fact PM, Pn, Px, Py, whatever you have been assumed is true by the help of that. So this principle is known as principle of mathematical induction. So during the principle of mathematical induction to prove the binomial theorem for positive integral index, we may use the identity NCR plus NCR minus 1 is equal to NC, N plus 1 CR. That's the way. But we may use the continued product in proving binomial theorem for positive integral index. Look at how. So we all know here x plus a raised to the power of n. Look at here, it is the positive integer only, not for any index. Still we have a binomial theorem for any index, but right now we are taking binomial theorem for index only. So what we know that it is NC0 x to the power of n minus 0 a to the power of 0. Now the second term is NC1 x to the power of n minus 1. Look at here, n minus 1 and a to the power of 1. And third term NC2 x to the power of n minus 2 a2 and so on and so forth. If we write here like that NCR, then we have to write x to the power of n minus r into a to the power of r and so on and so forth. The final term or the last term is ncn x to the power of n minus n a to the power of n. This is called binomial theorem of positive integral index. So just we are going to prove this one by using the continued product. Okay, so what here, a1, a2, a3 dot to n, only we have to put a1 is equal to a2 is equal to a3 is equal to an is equal to a. Then what we get on the left side, x plus a, x plus a, x plus a, x plus a. If you multiply all together, we will get x plus a to the power of n. And what about right hand side? Look at. So this is just I am going to prove this one. So we have to keep it intact, and now just we are going to write here. Look at. So here on the left hand side is x plus a, x plus a, x plus a, and so on and so forth, x plus a. This is here x to the power of n plus, this is a1 plus a2 plus a3 dot plus a. So all are a, so it becomes na here, na, n into a. And now here x to the power of n minus 1 and so on and so forth up to here. Look at, so last term is what here, last one is here a1, a2, a3 dot to n. Okay, so a1, a1, a1a, a2a, a3a dot to a and a, so it becomes a to the power of n. So look at here, a to the power of n. How one can get this one? Because we have used the fact a1 is equal to a2 is equal to a3 is equal to dot n is equal to a. So now on left side it becomes x plus a to the power of n. Now here is the one. So just I want to give you a clip here. What is the meaning of NCR? So firstly, or it stands for what? Combination of or selection of are things from given and different things. That is called NCR. Different, mind you, and different things NCR. And it comes out to be factorial n over factorial r into factorial n minus r. Factorial notation. You might use this notation as well for factorial, but nowadays this notation is obsolete, that is no longer in use. That is why this notation. Only one, what we have to use factorial and what is the meaning of factorial. So only exception is that factorial 0 without any proof taken as 1. However, there is no factorial notation for negative integer or for any fraction, whatever it may be, proper fraction or improper fraction. So only for positive integer. So factorial for any positive integer. So exception is 0 here. if n is positive integer, you may call it natural number. That's good. Okay. This is definition. So look at here, what is the value of NC0? What is the value of NC0? Here is the factorial NC0. Firstly, we write like that, factorial n, factorial 0, factorial n minus 0, factorial. This comes out to be n factorial, 0 factorial, n factorial. So it is not 0, so it cancel out, and factorial 0 is 1. So it is 1 over 1 is equal to 1. So here for this one, we may write NC0. So put it here, NC0, x to the power of n. However, you may write here, because look at here, a to the power 0 is equal to 1, and it is not defined, or one cannot write any values like 1 if a is equal to 0. So here understood a is not equal to 0. Then okay. So we may write here a to the power of 0. Then we have to think about n into a. So we have to think about NC1. NC1 here, not about n. We have to think about here n. So here NC1. So what is it? Comes out to be factorial n, factorial 1, n minus 1 factorial. So here factorial n may be written as n minus 1 factorial. So here is factorial 1 n minus 1 factorial. So this is not 0 and defined as well, so it cancel out. So factorial 1 is also 1, so n over 1 is equal to n. So in place of n, because here two factors, that is why we have said earlier we have to think about n into a. So here n, in place of n, we may write here NC1. So here it is NC1. So look at here, x to the power of n minus 1. Here is a, so we may write here a to the power of 1. So look at, just we are going to get the terms on right hand side. That's fine. In a similar manner we may get, and finally we get a to the power of n. So again here is 1. So for this one we write NCN also. Why? Look at here, NCN. So what we are going to write? N factorial, n factorial, n minus n factorial. So here n factorial, 0 factorial. This comes out to be cancelled because not 0 and defined as well, and factorial 0 is 1, so 1 over 1 is equal to 1. So here for NCN, right, with the fresh letters here, NCN, a to the power of n. Why not? X to the power of n minus n, means x to the power of here n minus n, that is the 0, 1, and here a to the power of n. So look at left hand side already proved here, and the right hand side by simple manipulation you may get. Now we can say that it is look like binomial theorem for positive integral index. That is why it is proved quite easily. However, we have an alternative proof too, but right now we are not going to indulge in that. We will see more when we will take up binomial theorem chapter on algebra. Okay, so there are things. Now just we are going to take an interesting example on that continued product. So now so question is, find the coefficient of coefficient of x to the power of 99 in p of x is equal to x plus 1, x plus 2, x plus 3, dot dot dot, x plus 100. So just we have read continued product, that is we have to multiply these factors, but I have told you earlier in this class the coefficient of x in every one of the factor must be unity. Yes, it is. So readily we apply. So here take x from each of 100 factors, then it comes out to be x to the power of 100. Now x from 99 factors and the numbers from remaining one. So what we are going to get? Obviously, as per continued product, it comes out to be 1 plus 2 plus 3 dot dot plus 100, x to the power of 99, and so on and so forth. But we are interested here in the coefficient of x to the power of 99. Here the coefficient of x to the power of 99 is this one. So we arrived on our answer. Therefore, the coefficient of x to the power of 99 is equal to 1 plus 2 plus 3 dot 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 plus 100. So use the result what we have learned in the first class, n into n plus 1 over 2. So here n is 100, so here is the 100 multiply 100 plus 1, 101 over 2. So it comes out to be here 50, multiply it, we will get 50, 50. That is our answer. Now just we are going to take the next question. Question number 1 here, question number 2. Find the coefficient of x to the power of 99 in p of x is equal to twice x plus half, twice x plus 1, 4x plus 1, 8x plus 1, and so on and so forth up to 100th factor. No. Just we are interested in using the continued product. But prime criteria is that in every one of the factor, the coefficient of x must be unity. But here not so. So firstly, we have to make the coefficient of x in every one of the factors unity. How is it possible? Quite easily. Why? Because take 2 common from first factor, 4 from the second, 8 from the third, and so on and so forth. So here it is 2 to the power of 1 x plus half. Here 2 to the power of 2 x plus 1 by 4. So just we are writing 2 to the power 2 and 4. You may write here 2 to the power 2, no problem at all. So why I am going to write in the manner? So you may write here, no problem at all, 2 to the power 2 here. So here 2 to the power of 3 common, x plus 1 by 2 to the power of 3 in a similar manner. So here 2 to the power of 100 because 100 factors in that particular problem. So here take it common, so it comes out to be x plus 1 over 2 to the power of 100. Now look at here. Firstly, 2 to the power 1, 2 to the power 2, 2 to the power 3, and so on and so forth, 2 to the power 100. So as from class 6, we all know, on the same base, power will be added if they multiplied together. So here they are multiplied together. So we are able to write here 2 to the power of 1 plus 2 plus 3 dot 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 plus 100. Now here x plus 1 by 2, x plus 1 by 2 to the power of 2, x plus 1 by 2 to the power of 3, and so on and so forth, x plus 1 by 2 to the power of 100. Now here what? So this is the factor, however numeral factor is multiplied to every one of the power of x if we multiply these 100 factors together. So that's the common for every one of the term. But we are interested in the coefficient of x to the power of 99. And therefore, we have to multiply, but the prime criteria is fulfilled. So in every one of the factor, look at here, the coefficient of x comes out to be unity. So this factor is here, carry this one. So this is p of x is equal to 2 to the power of, we have seen just before, 50/50. Now here x to the power of 100, because we have taken x from each of 100 factors and then multiply together, comes out to be x to the power of 100. Now from 99 factors we are taking x, and from the remaining one taking the number. So x to the power of 99 comes out to be common. So here we have 1 plus 2, not 1 plus 2 here, look at here, 1 by 2 plus 1 by 2 divided by 2, 1 by 2 to 3 dot 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 1 by 2 to the 100. So here we write quite easily here half 1 by 2 2, 1 by 2 to the power of 3, and so on and so forth, 1 by 2 to the power of 100, and then multiply here x to the power of 99 plus so on and so forth, because we are not interested in those terms, because our task is that to find the coefficient of x to the power of 99, that is why. So now therefore the coefficient of x to the power of 99 is equal to what? 2 to the power of 50/50, and then 1 by 2, 1 by 2 to the power of 2, 1 by 2 to the power of 3, and so on and so forth, 1 by 2 to the power of 100. So look at the series in GP. However, we will learn in a length when we will take up series, so arithmetic, geometric, and harmonic series. So we will take up in detail there, but right now just we are going to use the result. So here 2 to the power of 50/50, and here, so sum of this 100 terms, it comes out to be 1 minus r to the power of n divided by 1 minus r multiplied by first term, where r is the common ratio. So here 2 to the power of 50/50, so here is a is already half, here 1 minus half to the power of n, here n is 100, 1 minus 1 by 2. So here 1 minus 1 by 2 is half is cancelled here. So it become like that here. So it comes out to be 2 to the power of 50, 50 multiply 1 minus 1 by 2 to the power of 100. That's your answer. So in this way, we are able to find the coefficient of x to the power of 99. Now, the question number 3. Question number 3 is here, find the coefficient of x to the power of 98 in p of x is equal to x plus 1, x plus 2, x plus 3, so on and so forth, x plus 100. Just we want to find the coefficient of x to 98. However, we may find the coefficient of x to 97, 96 and so on and so forth, but in general it comes out to be very lengthy. So in this course of class 11 and 12, so it is not required to find the coefficient of 96, 95 and so on in that particular sum or like that. So that is why we have to confine ourselves here up to the coefficient of x to the power of 98 in that type of sum. So before indulging in that, we have to know an input. So firstly, we are going to discuss of that. Look at here. So here a1 plus a2 whole square. So we all know here a1 square plus a2 square plus twice a1 a2. Now here a1 plus a2 plus a3 whole square. So it comes out to be a1 square, a2 square plus a3 square plus twice a1 a2, a1 a3, a2 a3. Now again here a1 plus a2 plus a3 plus a4 whole square. This comes out to be a1 square, a2 square, a3 square, a4 square twice a1 a2, a1 a3, a1 a4 plus a2 a3, a2 a4 plus a3 a4. It is quite easy to write, only we have to take care about make all possible pair from a1. So look at here a1 a2, a1 a3, a1 a4. In a similar manner, make all possible pair with a2, not going backward, only move forward a2 a3 plus a2 a4. From here a3, a3 a4 only. Do not move backward because we have taken already. So it may be double or triple. So take care of that. So only we have to move forward and like that. On a similar manner, we proceed from here. Here is the a1 plus a2 plus a3 plus dot 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 plus an. So this that much whole square is comes out to be here. So unable to write all of them. So here a1 square plus a2 square plus a3 square dot 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 plus an square plus here. Plus here I am going to write from here. Why? Let us see. Twice a1 a2, a1 a3, a1 a4 plus dot 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 plus a1 an plus move forward from a1 all possibility, from a2 forward all possibility, a2 a3, A2, A4, A2, A5 plus dot 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 plus A2, AN. Now from A3, all possibility in forward direction. So here A3, A4, A3, A5, A3, A6, so on and so forth up to A3, AN. So look at here, from A1, 3 and then generalize, from A2, 3 and then generalize, from A3, 3 and then generalize. Here I missed here plus sign. Now look at as a whole. This is the one, this is the two term taken all together, this is the third one, and then now we have to generalize, write the final pair, AN minus 1, AN. This is the final pair. This is the final pair. So this is twice of that. Okay, take the bracket, close here. So what? A1 plus A2 plus A3 plus dot dot plus A in whole square comes out to be that much. But we are going to write this one in compact form. Look at here how one can write it into compact form. So for this one here, sigma AI, I is varying from 1 to n whole square. On the right hand side, sigma AI square, I is varying from 1 to n, plus twice sigma AI AJ I comma j varying from 1 to n, and I is not equal to j. Think over, after pausing the video, you may think over why not here I is not equal to j. Pause for a while, then you will watch the video. Okay, just I am going to say the answer here, because you are also able to find the answer quite easily. Just I am saying like that. If I is equal to j here, so a square is there, but a square is already taken earlier, so that is why I is not equal to j. Okay, the only reason is that. The reason is the answer is quite easy, but you may think over it. So here, this is in compact form, this is in expanded form. So now we are able to find the answer of that. Let us see how. So again, let us see, is continued product applicable? Answer is yes, because in every one of the factor the coefficient of x is unity. Okay, we may apply here. So it's the 100 factor, take x from every one of the factor and multiply it together, then we will get x to the power of 100, and x from 99 factors and number from remaining one, what we have seen earlier, then it comes out to be 1 plus 2 plus 3 dot 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 plus 100 x to the power of 99 plus x from 98 factors and numbers from remaining 2, and then multiply together. So what we are going to get? X to the power of 98 in every one of the term. So take it common. So here what we have to write? 1 into 2, 1 into 3, 1 into 4, plus dot 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 plus 1 into 100 plus 2 into 3 2 into 4, 2 into 5 plus dot 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 2 into 100 plus 3 into 4, 3 into 5, 3 into 6 plus dot dot plus 3 into 100 and dot 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 plus lastly the last pair. So 99 into 100, and then what we have to take here, the bracket here, parenthesis. These terms are closed by parenthesis, and then multiply it by x to 98 and plus so on and so forth. But we are interested here in the coefficient of x to the power 98. That is why we are not interested in writing the remaining terms containing the lesser power of x, x to the power 97, 96, 95 and so on and so forth. We are not interested in that because we have to find the coefficient of x to the power of 98. So now what we have to write here, say here, is S2. What is S2? That much. Now in compact form here, sigma 1, 2. It is understood, so that much. If context is very clear, so no need to write here the limit on that summation sign. Context is very clear. Okay. So we have to find sigma 1, 2. That's the little bit difficult, but in my dictionary there is no word like difficult, because if we know this result then it is quite easy. If it is difficult, then difficult for everyone, but it is not so. Those who know this result able to solve quite easily. So now we are going to use the result what we are waiting for. So just we are going to use the result here, 1 plus 2 plus 3 dot 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 plus 100 whole square plus 100 whole square is equal to 1 square, 2 square plus 3 square dot 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 plus 100 square plus twice sigma 1, 2. And we are interested in sigma 1, 2 here. So look at from here, this implies sigma 1, 2 is equal to, this is, you know, n into n plus 1 over 2. So here this is 50-50, because we have seen today in the earlier problem, this is 50-50 whole square. The minus, this one you all know, n into n plus 1 into 2n plus 1 over 6. So n is 100. So here it is the 100 multiply 101 multiply 2 into 100 plus 1. That means 201 over 6. Whole divided by, this is the 2 here, half comes on that side, becomes 1 by 2. So this is the answer of the coefficient of x to the power of 98. So if 97, 96, we are able to do that, but these types of problem is generally not fit for class 11 and 12. That is why leave it here and enjoy up to this stage. Okay. So now today just we are going to write the definition of physics, and we will explain the definition of physics in conjugation with the mathematics in the next class. So look at here. Question here, what is physics? Answer is here. It is thinking or imagination of natural phenomena, which is plural of phenomenon. It is thinking or imagination of natural phenomena, which is plural of phenomenon. Phenomenon means one incident. Phenomenon means too many incident, too many thinking, too many imagination. Phenomenon means imagination. So one cannot conclude thinking is one or thinking is two, but for the clarification of this definition, I am saying like that. Now it is not yet complete. We perform precise and accurate experiment in the laboratory. Obtaining result we may express in simple mathematical relation by means of number one, expression. Maybe in identity, maybe in the form of equation, or in the form of inequality, and inequation. This is complete and exhaustive definition of physics. It includes everything. Natural phenomena. Okay. What is happening in the nature? Everything happening in the nature. So it includes every one of these subjects, because everything happening in the nature. However, their modes of study are different. Okay. Now we people are specified. This is physics, this is chemistry, this is mathematics, biology, and so on and so forth. We did, but nature has nothing to do with that. So that is why natural phenomena. Imagine, we have to imagine something. Okay, so I imagine here, just I am moving in the sky, crossing the Mount Everest, like that. That's the imagination. You have to imagine in front of you a sphere of radius 10 centimeter, the color you like most. These are the imagination. We have to make the inclined plane here. We are going to make the inclined plane on the white paper or the ruling paper. Why not here? Here is the force, here is the mg, here is the theta, like that. So imagine, this is the imagination. This is the imaginary world. You have to imagine. So thinking or imagination. Okay, we perform precise and accurate. We will discuss in the next class what are the meaning of precise and accurate, or subtle experiment, you may say. In the laboratory, obtaining result we may express in simple mathematical relation. Here, simple mathematical relation. By means of expression, identity, equation, inequality, and maybe in the form of inequations. That's okay. Just I'm going to finish the lecture here. In the next class, we will discuss what is the meaning of precise and accurate in very detail, because this will give you insight how one can understand the significant digit, the concept, scientific notation, rounding of a number, etc. So, by the understanding of precise and accurate, we are able to understand those things quite easily. Now, for this section, expression, identity, equation, inequality, and inequations, we will discuss it in a length, so that will provide you comfort in physics of any level, either of class 11, 12, undergraduate or master degree physics. So these 5 things is very, very essential. You also know there is a 5 sense organs. There are 5 number I have told you in the first class, the very nice number. So here also a very 5 comes frequently in physics and mathematics. So we will discuss these things, keeping in mind what or in which way we will use these results in physical world. Okay, thank you.